In this example, we're going to examine the proportion of male babies using the normal approximation method and hand calculations. Here's our research question. Is the proportion of babies born male different from 0.50? In a random sample of 200 babies, 96 were male. From this scenario, we know that P, or the hypothesized population value, is 0.50, N, our sample size, equals 200, and P hat, the sample proportion, is 96 over 200, which equals 0.48. Let's use the 5-step hypothesis testing procedure to examine this research question. Step 1, check assumptions and write hypotheses. Recall, in order to use the normal approximation method, both n times p and n times 1 minus p must be at least 10. N times p is our sample size times the hypothesized population proportion. 200 times 0.50 equals 100. N times 1 minus p equals 200 times 1 minus 0.50, which also equals 100. Both of these are greater than or equal to 10, so this assumption has been met, and we will use the normal approximation method. Now let's write our hypotheses. Our research question was, is the proportion of babies born male different from 0.50? The key word here is different. This is a two-tailed test, or a non-directional test, because we are not given a specific direction. Our null hypothesis is that P, the population proportion, equals 0.50. Our alternative hypothesis is that P does not equal 0.50. Step 2, calculate test statistic. Here's the formula for a z-test statistic from your online notes. Z equals 0.48 minus 0.50. This is the difference between our sample proportion and the hypothesized population proportion, divided by the square root of 0.50 times 1 minus 0.50 over 200. This is our standard error. In this case, our z-test statistic equals negative 0.566. Step 3, determine p-value. Recall, our alternative hypothesis was that p does not equal 0.50. This tells us that this is a two-tailed or a non-directional test. Our z-test statistic was negative 0.566. We're going to go to Minitab Express to construct a z-distribution, and we're going to look up the area that is more extreme than z equals negative 0.566. Here in Minitab Express, I'm going to construct a probability distribution plot. I want to display the probability on a normal distribution. Recall, a z-distribution is a normal distribution with a mean of 0 and a standard deviation of 1. We have a z-value, and we have a two-tailed test. Our z-test statistic was negative 0.566. This will give us a probability distribution plot of a z-distribution, shading in the region that is more extreme than a z-test statistic of 0.566. Our p-value is the total area that is shaded in red here. 0.285697 plus 0.285697 gives us a total shaded in region of 0.571394. This is our p-value. Step 4, decide between null and alternative hypotheses. We just found our p-value to be 0.571394. We're going to use a standard alpha level of 0.05. Our p-value is greater than this alpha level, so we fail to reject the null hypothesis. Step 5, state conclusion. We failed to reject the null hypothesis, so there is not evidence that the proportion of babies born male in the population is different from 0.50. Our results are said to be not statistically significant.